Okay, hi everyone. Here we will be entering chapter 9, and this is actually a supplementary worksheet. And in this particular video, we'll go through the few concepts on how do we determine whether a relation is a function, right? And how do we define a function? And how do we find the range of a function? So, namely, these three skills. Okay, so without further ado, let's start and go one by one. Okay, so concept number one. Okay, so how do we determine whether a relation is a function? Now, you should know that there are many kinds of relations, or many kinds of mapping between the input and the output. So namely, we have the one-to-one mapping, we have the many-to-one kind of mapping, we have the one-to-many mapping, and at the same time we can have the many-to-many kind of mapping, right, which is actually very complicated. Now, out of these four kinds of situation, only two of them are functions. So the thing is, only one-to-one and many-to-one relations are functions. Okay, so why is this so? Okay, why is this so? Because the function is defined such that every input, right? The concept of the function is that every input has only one output. Okay, doesn't have to be a unique or a different output. It can be the same output, but all they want is just one output. Okay, so every input or every object must have one output. And if the object or if the input, right, does not result in any output, there's no output, that will not be a function also. Okay, so what we're going to do is the test, and to test to see whether y equals to fx is a function or not. Okay, so what we're going to do is we're going to sketch the graph, and we're going to do a vertical line test. Okay, so this test over here is going to be a vertical line test to see whether the graph or the relationship is a function or not, right? So this will tell us whether is this a one-to-one and a many-to-one function. Okay, so the criteria is over here: the vertical line intersects the graph exactly once. So this is the vertical line test. Now then, next, how do we define a function? So function is, now fx is over here. Now this is the rule. Okay, the rule is actually over here, right? Or more like this whole thing is the rule or the expression or the formula. And over here is the domain. X belong to which set. And for functions, it is important for us to specify the domain. Okay, now and then what is next is, now in order to find the range of the function, okay, so we'll have different methods. Okay, now the analytical or algebraic method, right, is something that we'll cover in it's not really recommended lah, or you can cover this in a university, right? But the thing is that it may be a bit like there will be logical gaps if you just apply it directly, and you need to be very strong to know what are the mappings of the different functions, right? So what are we going to do in A level is the method is to use the graphical method. So we actually see the domain and the range of function from the graph itself. Okay, so what we're going to do is we're going to sketch the graph, right? And the range of f would be the set of y values for which the graph is defined. Okay, so without further ado, let's take a look at some of the examples below, right? And to determine the range of these following functions. Now let's take a look at example 1, right? To find the range of this particular function. So fx is this expression 4x plus 1 over x minus 3. So we want to find the range of f. So over here, you need to recognize that this is actually a rectangular hyperbola, right? So how do we find the range again? We are going to look at the graph of this particular function, right? So we can rewrite the graph as this 4x plus 1 over x minus 3. So how do we obtain, right, a nicer form which will allow us to sketch the function, which is to do long division, right? So I will do something like this, right? And this will give me a 4, okay, plus a 13 over x minus 3, right? Then from here, this one will give us the horizontal asymptote. This one over here, x equals to 3, is going to be my vertical asymptote, right? Remember this concept? And let us try to draw the graph now. Okay, so we will first get the axis and also the asymptotes, right? And we will get our graphs like this. Okay, next is to furnish the x and y intercepts to see where we are looking at. Okay, so now not that it really matters anyway, right? So over here, right, if we were to take a look over here, now this line over here is actually the domain of f, so which means that it is spanning across here except for this line, right? So similarly, what we have over there is, right, so except for y equals to 4, the range above and below over here, no, the length, the y values above and below over there are actually the range of f. So this set is actually the range of f. So how do we express this range of f from a diagram over here to a written form? So from the graph, the range of f would be just all the real numbers except for 4. Okay, all the real numbers except for 4. So it's like a minus the set of value 4. Okay, so a set of element 4 also can. Right, so this is how we do find the range of f, which is to sketch the graph, and from the graph observe where is the y value defined, and from there translate into mathematical symbols. So let's take a look at do-it-yourself one. We are going to look at fx and gx, right, and sketch on separate diagrams the graph of f, gf, and fgx. And then we want to determine the range of these three functions. Okay, so let's begin our work. Okay, so the first one, fx is x squared minus 1. Very easy. It looks like this. So y equals to fx over here, right? So now let us take a look at, because we are looking for the range, right? So let us take a look at, okay, so once again, the domain is everything. So the domain, right, of f would be just simply the whole of real numbers. Okay, now then what about the range? Means we're going to draw, we're going to see what are the range of y values. Okay, which is something like that, and this is our range of f. So how do we express this vertical range in mathematical terms over here? So the range of f would also would start from -1 to infinity, like this. Okay, now an alternative way of writing, right, would be like this, but it's going to be longer. So it will be y is a real number such that y is greater than or equal to -1. Okay, so take note, yeah. So when it will be equal to -1, we will use a square bracket. If you cannot equal the number, we will make use of just a regular bracket. Okay, so what is this actually? This is actually a set notation. It's just that it is in the interval notation, right? This is a set of real numbers between -1 inclusive and infinity, and this is a collection or is a set of all the elements or all the real numbers, right? So this and the set below, they are equivalent. Okay, so these are both sets, just that the interval notation looks a lot more compact than the other one. Okay, so this is the range of f. Now I know that we haven't really talked about composite function yet, but let's try to look for gfx, right? Gfx means I will pass through f first, then I will only pass through g. Okay, so this is the meaning of gfx over here, right? So what we're going to do is we will do the f first. So g of x squared minus 1, and then g is the modulus. So it's actually modulus of x squared minus 1, substituting the whole expression into the modulus, into the x. So you replace x with that lah, in a sense. Okay, so let's take a look at how should we draw this graph. Okay, so the graph will be the same as the previous graph, just that this portion we need to rotate upwards, okay, to become like this. Okay, so then we'll look at the range of values, range of y values for this function, okay, which will be like that, right? Over here, you can see it's going upwards. Now, so it's going to start from this line over here. Okay, so it's going to start from here. Okay, so how do we write this in mathematical symbols? The range of GF. Oops, so this is not fx, this is GFX. Okay, so the range of GF is going to be starting from 0 all the way to infinity, like that. Okay, so this is how we draw the graph of GFX, and from the graph, using graphical method, we determine the range of GF. Okay, last but not least, we have a FGX. How does FGX look like? It will be f of modulus x. Okay, so subbing modulus x into our equation of x squared minus 1. Now, x squared modulus is actually the same as x squared minus 1. So it's actually the same as our fx. Okay, okay, so exactly the same graph, exactly the same look over here, right? So what we're getting is range of fgx, range of fg would be starting from -1 inclusive all the way to infinity. Okay, so this is the exact same shape, right, as compared to part A fx. Okay, so that's all for this video, right? Hope this video will help you in order to obtain the range of the function, okay, using the graphical method.